Hello everyone. So we have discussed basic things in statistics so far. So today I'm going to discuss about some of the terminology, especially regarding the variables that we used in statistics and how to analyze the variables using statistical basic concepts in statistics, right? Okay. So these are the things that we are going to talk. We are going to talk about the nature and the types of data, the fundamental calculations in statistics, right? That is for the central tendency measures we are going to talk about, and then we are going to talk about the measures of dispersion, right? So we discussed in our previous lecture as well, when it comes to statistics, for some it's all about the numbers, and for some it's about the process of collecting, analyzing and presenting data, right? So anyway, statistic is an art. So it's the science of collecting, summarizing, presenting and analyzing data. So it's all about numbers and it's all about analyzing them, it's all about presenting them, right? Okay. So we discuss some of the terminologies in our previous lecture. What is data, right? We discussed data is the information that we collect from the individuals or the units of your research. Now, for an example, monthly airline passenger numbers and average yearly temperature of a city. Then patient satisfaction rating data of hospitals. All these information that we gather, we call them as data. And then I told you there are two types when it comes to a data set. We have elements. If just to remind you all, if you are doing the research about university students, then you have the students are the elements. Elements means the entities that we are collecting data from, right? So when it comes to those elements have special characteristics. If you take a student is having a gender, age, maybe the hometown. So these characteristics, they are varying from student to student. So we call them as variables, and we discuss some of the variables we can measure numerically. We call them as quantitative variables. Some we cannot. We call them as qualitative variables. So if you look at this data set, so here you can see you have brand and model, price, and the sound quality, CD capacity. So this brand and model, price, sound quality, CD capacity, these are the variables, right? And here you have different brands. It's like different students, so they are the elements, right? So if you take IVA and if you take JVC, FS, the price, sound quality, CD capacity, it's varying from one to another. So you have these three variables for each and every brand and model, right? So if you take a particular row in a data set, for an example, if you take Panasonic SC PM11, the price is $170 and the sound quality is fair, CD capacity is 5. So if you take this one row, we call it as an observation. So all the characteristics belongs to one element, you call it as an observation, right? So this one we have already discussed. So when it comes to numerical variables, that is the variables that you can measure numerically, there are two types. Some we call as the discrete type variables and some we call as the continuous variables. In discrete type variables, you can measure them numerically, but we can use only the whole numbers. For an example, if you take the number of family members, we can't record it as 2.5, right? It's 1, 2, 3. It's always a whole number. You cannot take decimal places. But if you are measuring height, weight, maybe your height is 5.5 feet. right? Maybe your weight is 62.5 kilograms, right? In there the decimal places are possible. So if you can record a numerical variable with decimal places, we call it as a continuous variable, or else we call it as a discrete type variable, right? And the qualitative, quantitative, we know if you are using numbers, if you can measure is numerically, if you have a numerical meaning, we call it as a quantitative variable. If not, we call it as a qualitative variable, right? So if you look at this basic example, now we have a population which consists of bulbs, which is manufactured with in a factory with a new filament, but the average lifetime of this bulb is unknown. So our task is to find out the average lifetime of this bulb. Okay, so what can we do? We are going to take, as the first step, we have to decide how many bulbs we are going to check in order to take this conclusion. So we are going to select 200 bulbs with this which are manufactured with this new filament, right? And then we are taking the average lifetime of these all 200 bulbs, and then we are taking the lifetime of these all 200 bulbs. Then we can calculate the average, right? Take the summation of all 200 and divide by 200. Then we can take the summation as, let's say, it's 76 hours per bulb. So then we can get into a conclusion that when you take a bulb which is manufactured with this new filament, on average it has a lifetime of 76 hours, right? So it may be same as all the bulbs in this population. So that based on the sample we give a conclusion about all the bulbs in the population. So that's how we are making inferences about the population using sample data, right? Okay, so to do the fundamental calculations, I have very few questions here. So this is the data set. So the first question is, how many elements does this data set contain? So the brand is the element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 elements, right? And then what is the population? So it says the data set obtained from a sample of 10 all-in-one sound systems called mini systems, right? So this is a sample of 10 mini systems. So the population should be all the mini systems in the world, right? All in one mini systems in the world, that would be your population. So compute the average price for the sample. So you have the prices. If you want to calculate the average price, what you have to do, you have to take the summation of all the prices and divide it by 10, since you have 10 models here, 10 elements here. And then you have the next question is, using the results in parts, this should be part 3, estimate the average price for the population. Now when you calculate the average for the sample here, you can say that is true for the population as well. For an example, let's say the average is $175. So the population also, we are giving the same estimate, right? On average the population price is also could be $175. And then the next question is, how many variables are there in the data set, and identify which are quantitative and which are qualitative. So you have price, sound quality, CD capacity, FM tuning, tape decks. So these are the variables. If you take price, you can record it numerically, so it's a quantitative. Sound quality, it has no numerical meaning, it's a label, so it's qualitative. CD capacity, you can record with numbers, has a numerical meaning, quantitative. FM tuning, it's just a label, then qualitative. Tape decks, you have the number of decks, there, so that is again a quantitative variable. And then what is the average CD capacity for the sample? So you have the CD capacities here, right? 3, 1. So you have to take the totals. Those that is 3 plus 1 is 4, 4 plus 3 is 7, 7 plus 5 is 12, 5 plus 12 plus 3 is 15, and then 15 plus 3 is 18, 18 plus 3 is 21, 21 plus 5 is 26, 26 plus 3 is 29, 29 plus 1 is 30, and the total is 30. You have 10 elements here, so 30 divided by 10, that is 3. So that is the average CD capacity is 3. And then what percent of mini systems provide an FM tuning rating of very good or excellent? So here the FM tuning, very good or excellent, you have 1, 2, 3, 4, 5, 6, 7. Out of 10, you have 7 with very good or excellent ranking. So 7 divided by 10. Since they are asking about a percentage, you have to multiply that by 100. So that is 70%. Last question, what percent of mini systems include 2 tape decks? So that is you have 1, 2, 3, 4. Out of 10 you have 4. So 4 divided by 10. Since they are asking for a percentage, you have to multiply by 100. That is again 40%. Right? So based on your data set, you can do a very fundamental calculation like this. Okay, so when it comes to this variables, again we have a measurement scale in variables. Now when it comes to the qualitative variables, where you have no numerical meaning, where you have labels, again we can categorize them into 2 parts, as the nominal variables and as the ordinal variables. So nominal variables are like you are using just labels to recognize them, and you have no order. For an example, if you take gender, you have male and female, just 2 labels, but there is no hierarchy, no order between males and females. You can't say males are higher than females or females are higher than males. So that is, there is no hierarchy. So that is coming under the nominal category. But when it comes to the educational qualifications, if you take O levels, A levels and degree and PhD, there is a hierarchy, right? So in that case, you can see a particular order. So if you can see an order in between the labels, we call it as the ordinal scale. Right? When it comes to qualitative, you have the nominal scale and you have the ordinal scale. And when it comes to the quantitative variables, we have again 2 measurement scales. That is, we have interval and we have ratio, right? So in this case, how do you identify interval and ratio? So if you have when it comes to the interval ratio, interval scale, the best example for the interval scale is here. If you see the scores of the students, right, the scale of measurement for variables become interval scales if the data show the properties of ordinal and the interval between values is expressed in terms of a fixed unit of measure, right? So for an example, now let's say student 1 scored, if you look at this example, there are 3 students, and their scores for some certain examination are 620, 550, 470. So if you just take the difference between these scores, if you just take the difference between 620 and 550, 70 points, that is, the first student is 70 points ahead than the second one. So there is a meaning between the differences. If so, we call them as interval scale data. right? And also uh, in this case, if you take the interval scale data, we don't have a true zero value. That is now another example for interval scale is the temperature. So when you say temperature is zero, it doesn't mean that there is nothing. There's a meaning for that. So we say that is not a true zero value, because when you say zero, we believe that there is nothing, right? So if you have no true 0 point, that comes under the interval scale, where when it comes to the ratio, you have a true zero value. That is when it comes to height, weight, when you say zero, that there is nothing, right? So it has all the interval, when it comes to the ratio scale, it has the properties of all the interval scale, plus it has a true 0 point, right? So that those are the difference between the measurement scales of the variable. So that is also something you have to know. And now when you have a data set, you should be able to do very fundamental calculations using your data set. So the very basic calculation you can do is to find the mean. So in order to find the mean, you should have a quantitative variable. You need numbers. So if you are provided with set of numbers, you can find the mean, the average. What you can do is you simply take the summation of all the values, divide by the number of values you have in the sample, right? So that is, if you have, for an example, let's say 1, 5 and 3, so you take 1 plus 5 plus 3, that is 9, and since you have three numbers, you divide by 3, so the answer is 3. So the average for that sample is equal to 3. And then you can find the median values. The median is the value which is in the right in the middle of your data set. So if you are interested in finding the median, what you can do is, first you can arrange your data set in ascending or descending order, and then find the position of the median. So to find the position, you take this equation, that is, you have to add 1 to your data set. That is, if you have three numbers, 3 plus 1 is 4, divide by 2. 4 divided by 2, 4 divided by 2 is 2. So at the second position, you can find the median value, right? So if you like have let's say 6 data points, 6 plus 1 is 7, 7 divided by 2 is 3.5. In that case, you have to take the value which is in the third position, fourth and the fourth position, then take the mean value as the median. And then you have the mode. We know mode is the value which has the greatest frequency, or which appears many times in your data set. So when you can observe the mode when you look at your data set which has the greatest frequency. So in some data sets you have no mode values, in some data sets you have two modes values, some you have one mode value, and some you have more than two as well, right? So if you are provided with, this is an example where you can try, if you are provided with the data set like this, you can easily find the mean, median and mode. So what you can do is you can take the summation of all these values, divide them. Here you have 1 2 3 4 5 6 7 8 9 10, divide it by 10 and find the mean. And 10 plus 1 divided by 2 is 5.5. First you have to arrange this in ascending or descending order and take the fifth and sixth observation, get the total, divide by 2 to find the median. And then if you look at this one, you can see 27 appears 2 times, 25 appears 2 times, and yes, so you have two modes in the first data set, that is 25 and 27. Like for each and every data set, you can easily find the mean, median and mode, right? And the next thing is the percentiles. Percentiles are also very important thing when it comes to statistics. So if you are provided with the data set, we can also find the percentiles as well. How we are going to find the percentiles? What does mean by the percentile? That is, if you find the pth percentile, that means at least p% of the observations are less than or equal to this value. For an example, if you find the 20th percentile for a data set, if you say 20th percentile is equal to 15, that means from the whole data set, there are 20% of the values which are less than or equal to 50, right? So in order to when it comes to percentiles, the quartiles are special kind of percentiles. Actually, we are interested about three quartiles, that is the first quartile, second quartile, and third quartile. The first quartile means the 25th percentile. Second quartiles means the 50th percentile. First quartile means the 25th percentile, second quartile means the 50th percentile, and the third quartile means the 75th percentile. That is, when you take the first quartile, 25% observations are less than or equal to the first quartile. And when you take the second quartile, 50%, that is exactly half of the observations are less than or equal to this value. So actually that is the value which is right in the middle. In other words, the second quartile, the 50th percentile, is the median value. Right, so when you take the third quartile, that is 75% of the observations are less than or equal to the third quartile. So in order to calculate, we can just first find the position of the quartiles, right, by these equations, right? And that is, if you have let's say if you have 11 observations in your data set, so 11 plus 1 is 12, 12 divided by 4, the position is 3. So at the third position, when you are in them in ascending order, that would be the first quartile. Likewise, you can find the quartiles, right? So there are some rules, easy rules that you can find to use the quartile. So if when you are finding the position, if you get an exact number to find the quartile, no problem. But let's say when you get for the position you get a number like 2.5, so what you have to do is you have to take the second value and the third value and get the average. But let's say you get something like 2.75, then what you have to do is you have to rank this into the next largest integer, that is 3, and you have to take the value at the third position, right? Right, so you have to round this to the nearest integer. Now let's say you get this as 2.1, so the nearest integer would be 2. So if you not get a whole number or a fractional half, you have to round that for the nearest integer. So you can just find out, you can take this data set and find out first quartile, second quartile, and third quartile, and then you can find the interquartile range. If you can remember, I'm sure that you have done this many times when you were schooling also. So we know when you take the difference between the third quartile and the first quartile, we call it as the interquartile range. So you can take Q3 minus Q1 and find out the interquartile range. And then we are also interested about the measures of dispersion or the variability. That is how far your data set is spreaded, the variation of the data set. So one measurement is this interquartile range. You can take the difference between Q3 and Q1. So that is the interquartile range. The middle 50% of your data is distributed between these values. And if you take the range, that is the largest value minus smallest value, the range of your data set, that also gives a meaning about the dispersion. And the other thing is we can also calculate for a given data set the variance and the standard deviation. So that is also giving you an idea about the variability of your data set. For that, you can do is you can use this equation to calculate the variance. That is, x, you have to take observation and subtract the mean from the observation, take the squared value and take the summation of all the squared values divided by n minus 1. N is the sample size. But if you look at this equation, actually here you have the summation of the squared units. Because of that, we take the square root of the variance and we call it as the standard deviation. In most of the cases, we are using the standard deviation for the interpretation, because then when you take the square root of the squared units, we can convert it back to the same unit that we have gathered information, so it's easy to interpret. So we prefer standard deviation rather than using variance when you want to calculate the measures of dispersion. So the standard deviation is just the square root of the variance, right? So you have some questions where you can give a try at home, and if you have any question you can let me know. And then again we can calculate the weighted mean as well. Now for an example, for your, let's say, now if you take a particular module, you have continuous assignments, you have mid exam, you have the final exam, but when you get the grade for the exam, you don't take the summation of all the components and divide it by 3. Sometimes we are taking 20% from the mid, 10% from the continuous exam, and the 70% from the final. So for each and every component you have a percentage. We call it as the weight, right? So if you are given with the weight for each and every component, you can take the component and multiply it with the weight and divide it by the number of observations you have to calculate the weighted mean. Right, so you can just give a try for these questions. Okay, and I think we'll stop at this point. So next day we'll talk about when you have grouped observations, how are you going to deal them, how to do the fundamental calculations. Thank you.